Hello everyone, I am Assistant Professor of Kute Akshada from SND Engineering College and Research Center. In previous lecture, we have seen compressed natural gas, that is CNG. In this lecture, we have seen hydrogen gas. What is hydrogen gas? Introduction to hydrogen gas. Hydrogen gas is going to be the most popular fuel in the 21st century. It is an increasingly important fuel for impurities, vehicles, rockets, fuel cells, etc. Hydrogen gas produces a very high temperature, blue flame in combustion, and no pollutant is emitted in atmosphere by its combustion. It burns with blue flame of high temperature and releases no any pollutant. It has high calorific value. After the storage of crude oil fraction in the near future, hydrogen fuel is a zero emission fuel when burned with oxygen. Combustion engines in commercial vehicles have been converted to run on a hydrogen diesel mix in up to the 70%. Hydrogen fuel is zero emission fuel when burned with oxygen. It can be used in fuel cells or internal combustion engines to power vehicles or electrical devices. It has begun to be used in commercial fuel cell vehicles such as passenger cars and has been used in fuel cells buses for many years in Western countries. Minor modifications are needed to the engines as well as the addition of hydrogen tanks at a compression of 350 bars. It can also be used for heavy duty vehicles where it is expected to run 300 km, 70 kg, which means an efficiency better than a standard diesel engine. Then we have seen the production of hydrogen gas. Hydrogen gas can be manufactured by various processes, of which steam reforming of methane is most widely used. Steam reforming hydrocarbons and coal superheated steam methods are commercial and economical. Then first type is commercial or industrial methods. In this method, it is a process of reacting steam with hydrocarbons in the presence of a catalyst at high temperature, obtain hydrogen and carbon dioxides. In this method, steam reforming of hydrocarbons are produced. We have used feed sulfur-free natural gas, naphtha, petroleum fractions. Catalyst used FeO, Ni or Fe. Temperature is 800 degrees Celsius and 370 degrees Celsius in shift reaction. Pressure lesser than 1 atmosphere. Next, shift reaction. This reaction produces more hydrogen by passing steam in the mixture of CO and H2. Explain industrial production of hydrogen by steam reforming of methane and coke. Then the CO2 plus H2 mixture is compressed and cooled to get liquid CO2 and H2 gas. The alternate way to remove CO2 from mixture is scrubbing the CO2 plus H2O mixture with alkali solution or solvent which can be recycled after evaporating out CO2. Explain industrial production of hydrogen by steam reforming of methane and coke. Next, coal and steam reaction. Coal on heating with superheated steam produces that water gas which is then reacted with more steam to produce additional hydrogen by shift. The H2 obtained this process is less. Hence this process is less preferred although very cheap method. And the H2 obtained in this process less associated with impurities H2S SO2. The reaction with more steam to produce additional hydrogen by shift reaction. Each carbon producing 2 H2O.